So we got to the point in our last video, I ran out of time, so I needed to continue. We've got this PR squared equals 16, so all we needed to do is be able to figure out what PR was. That's what was asked of us, and PR is of course just the square root of 16. So we end up with, and taking it to the 10th place, we're going to have 4.0 centimeters squared. So pretty straightforward. We're just using this formula and we're substituting some numbers in. We have another one here that we're going to go through, and this is a common one where you are given some directions. So you need to make sure you know your north, south, east, and west. Bellevue is 30 kilometers north of Ayr. So I'm going to throw in Ayr right here. That's a city in Waterloo or Kitchener, just outside of Waterloo and Kitchener in Ontario. Here's what we've got. There's Ayr right there. And it says Bellevue is 30 kilometers north. So we're going to go 30 kilometers north. There's 30 kilometers. And now we are in Bellevue. So we'll put Bellevue right here. Bellevue. Good. Now it says that Churchville is 18 kilometers northwest of Ayr. Northwest would be going in this direction, and it says it's 18 kilometers. All good. Now the only other thing we have is that we need to calculate the distance between, of course, Bellevue and Churchville. And by the way, I forgot to write down Churchville here, Churchville. Now notice we have an A and a B and a C, so we can actually just use angles A, B, and C as we go through here, but they've done that on purpose. So if I have this, I'm looking for this. Let's call this A, little a. Let's call the 30 kilometers. It's right across from Churchville, so let's do a little c. And we'll do the 18 kilometers, which is right across from Bellevue, little b, because of course we use the little letters to correspond to the angles. They also say that there was a degree, and then it says, what else do we have? It says that it is northwest. One of the things you need to know about when we say northwest, we're talking about a 45-degree angle. So keep that in mind when you see these kind of questions. North, of course, would be 90 degrees. Northwest would be a 45. So this is what we've got right here, a 45-degree angle right there. So now what are we looking for? It says we're looking for A. So I'm just going to use this formula again. This time I'm using A squared as what I'm looking for. We have a B squared plus a C squared. The formula is always the same, 2, and of course what gets filled in, I'm going to take that 45 out of there. What fills in is always this letter and this letter, so we're going to have a B, C, and those are multiplied together along with the cos. And in this case, it's cos A, which is Ayr, because we know that's going to be a 45 degrees. So when I plug in my numbers, I'm going to end up with 18 squared plus 30 squared minus 2, B was 18, C was 30, and the degrees in that angle, and remember that angle is contained between two sides, is 45 degrees. I plug that into my calculator. I end up with 460.32. If I take the square root of that, I end up with a 21.45, and that is actually the distance between Churchville and Bellevue. So you can see the real application to this using trigonometry is a very practical skill. All right, so that's it, and you should be able to do the next questions 1 to 4. I am going to continue on. Now, this is still based on the cosine law. All we're going to do is we're going to rearrange the cosine law so that in case I'm not actually looking for a side, I might be looking for an angle or a different side. We're going to just play around with it, and it just requires a little bit of algebra. So if we continue down, this won't take much longer just to get through this. It says, here's the equation. We know this. This is the basic equation. Here it is right here. That's the basic equation. And so now we can rearrange that. Now, how do we do that? Well, look at this. If I'm looking for the angle right here, I've just made a big yellow sign over at it. This is going to be the angle. So this is the one that's going to be contained between two of the sides that we've been given. How do we do that? Well, if I eliminate all the other stuff from the cos A by doing some division or adding or subtracting, I would be able to get cos A all by itself. So you can go ahead and try to figure that out. The only thing I would say, and if I was here I could show you a little bit more, but recognize this 2BC is multiplied. So how do I get rid of that? Well, by dividing both sides by 2BC. Also, I'm going to take my B and my C, I'm going to subtract B and C from both sides, so I end up getting it on the other side along with my A squared. So you can play around with that a little bit, and you can see that if I do some algebra, I will get this formula. And if you want me to run through that with some more algebra later, I can do that. Recognize, though, you can manipulate. Notice also, because I'm using cos A over here, the A is going to be the one that's going to be subtracted. You'll see some patterns. The B and the C will be added together, and you'll also have a B and C on the bottom. The B and C always correspond to whatever is on the top. All right, so let's complete the following. And by the way, when it says this form of cosine can be used to determine any angle in a triangle when we are given the length. So if I've been given a triangle and I've been given this side, and this side, I can then go ahead and use this form, the one I just put a check mark on. I can use this form to figure out one of the angles, whichever one that I'm looking for. All right, so let's do it. If I'm looking for B, then I'm going to just follow this pattern. I'm going to have a C squared plus an A squared, and remember what I just finished saying, the B is going to be the one that's subtracted. Notice in this case up on top, this A was being the one subtracted. Now I've got B here, so it's the one subtracted, and I have a 2CA on the bottom. To do the cos C, same pattern, I'm going to have my B squared plus my A squared. What am I subtracting? My C squared. And on the bottom will be 2, and it will be B, and it will be A. Again, keep looking for the pattern. It'll help you remember which way you're going. All right, now that we've got these two formulas, and you can always derive those on a test, you don't actually have to memorize them, you can derive them. Let's go on to the next page. We have two more examples, and then I'm going to leave you to work on these questions. Determine the largest angle in ABC. Okay, so I've got an ABC. I'm going to just draw a triangle right here. Okay, and I have an A, and I have a B, and I C. That's where I start. It says if A, which is the little a, over here is going to be 14.7. It's always corresponding to the angle across. B is 8.9. And C is 12.6. So there's the example of where I have all three sides, and now I am looking for the largest angle. Well, which would be the largest angle? It'll be the one that's opposite the largest side. I think you intuitively will recognize that. Biggest side, biggest angle across from it. Oops, touched the button again. So what am I looking for? I'm going to be looking for my A. So what do? I take what I've just learned and rearrange it. I'm looking for angle A. Remember what goes first is the B squared. I'm looking, and there's a C squared. I'm just doing this off the top of my head. I don't have it written down. And of course my minus A squared, because that's the angle I'm looking for. And on the bottom will always be the first two, B and C. All you need to do now is substitute all of these numbers in. I'm going to go ahead and do this. You can do this as well. Once I have all the numbers in, I've done some calculation. Again, encourage you to go ahead and use it on your calculator to do this. Make sure that you follow BEDMAS. remember that top of the numerator is all in brackets at the end. Then you figure out your denominator and then do that final division at the end. So I'm going to end up with, and if you have a problem with that, you go over it a couple times, talk to somebody beside you. Make sure you know how to plug this into your calculator. So the angle is what we just figured out. Angle A is, now hang on, remember we just finished figuring out cos A? So now how am I going to figure out the angle? Well, I'm going to use my calculator, and I'm going to use my second function, and because anytime I'm looking for degrees, I use that second function, cos A, with that number, and it will give me 84 degrees. Okay, you may want to stop and go over that again, but it's just pretty straightforward plugging it into a formula. Again, we can use this because we don't have a 90 degrees, we can't use trig ratios, we have to come up with a different way, and we're using the cosine law. Last one, same idea. We've got two ships, similar to the other question, where we have two ships set sail from port P, and they're heading in different directions. The first ship goes 7 kilometers to R, and the second ship, the first ship does, and the second ship goes 8 kilometers to Q. If the distance between R and Q is 13, what is the angle between the two ships? So we are looking for P. Now, just remind you, this is little q over here is little r, and over here is little p. So we're just going to use exactly the same law, the cosine law, and we go cosine, which is the angle I'm looking for? I'm looking for P. Therefore, I rewrite the equation, and I know that my other sides are going to go first. So I've got q squared plus r squared minus p squared, because that's the one that's associated with the angle I'm looking for. And on the bottom, always the first two, q and r, and you multiply that by 2. Substituting all your numbers, I'll stop talking for a minute. I'll plug in my numbers, you plug in your numbers. Again, you may want to stop this and make sure that everybody has it. I'm plugging in my numbers. And I'm going to get an answer of negative 0.5. All right. So here's the thing. This angle, if you notice, this angle at B is obtuse. So can you write that down somewhere? Angle is obtuse. You know obtuse means it's greater than 90 degrees. And notice this angle at P is greater than 90 degrees. So we need to find, we'll plug this in, because remember this is cos P is 0.5. Now, if I just go ahead and plug that into my calculator, I'm going to get a reference angle of 60 degrees. But remember, that's the less than 90 degree angle. So in order to figure out what the actual angle is, I'm going to have to take my 180 and minus 60, because I'm looking for an obtuse angle. I'm going to end up with 120. So again, we know this angle, the angle P, not B, sorry, angle P is obtuse. It has to be greater than 90 degrees. When I type this into my calculator, it's going to give me a reference angle of 60, but I know it has to be a bigger angle than that, so I'll subtract it from 180 and I will get 120. So just keep that in mind when you get to some obtuse angles. That is all. Your homework is to continue. So you're going to just do questions 1 and you're going to go to 9. Questions 1 to 9. And now you have the rest of the class to do that. I hope it all worked out. And if you need to replay this, I'm going to put it on my blog so you can watch it again at home if you need to. That's it. Have a good weekend. Bye.